The decision to build a road is the responsibility of the owner, the state, or the local authority. He should be responding to clearly defined needs, benefits, in the context of the risks involved. The benefits are economic development, improved transport, increased safety. It is then up to the chosen engineer to seek the most appropriate solutions corresponding to the quality and the level of service required by the owner. In this work, he should do his utmost to design technically realistic solutions, having taken account of any problems and the nature of the site itself. In any road project, the earthworks make up most of the material to be moved, have the greatest impact on the environment, and greatly affect the cost of the project. Particular care should therefore be given to this aspect. It should be noted that the cost of the earthworks amounts to about 1/3 of the total investment in a road project. For the best approach to the task in hand, the engineer divides his work into 3 main stages. The preliminary studies, the design, the tender documents. At the planning stage of the project, the preliminary studies serve to identify various alternative solutions. At this preliminary stage, the design engineer works with the basic earthworks that are dictated by the selected alternative alignments. Geological surveys identify the subsurface formations along the route and help to localize some of the hard rock areas. Hydrological and hydrogeological data are collected in order to calculate the flow rate of watercourses and to gain an understanding of water movements in the aquifers. The design engineer can then identify other potential problems as well as the potential risk to the lifespan of structures and the environment. The choice of alignment should take the topography into consideration in order to minimize the number of structures and ensure the best possible integration into the landscape. At this stage in the procedure, realistic alternatives can be evaluated. Once an alignment has been fixed, supported by all the necessary surveys and analysis of the alternatives, the design department can work to optimize it. At this stage, the topography needs to be more precise and the scale changes. Surveyors make a detailed survey of the route, which will then serve as a base map for all the related activities. At the same time, geotechnical specialists undertake a general survey of the alignment. Examples of difficult spots in the project are compressible soils, geological faults and discontinuities, unstable areas. These difficult spots will then need to be analyzed in detail in order to define the most suitable technical solutions. Once in possession of all this information, the design engineer can then make his choices. With a 3D view of his design constantly before his eyes, he can optimize central line of the vertical alignment by balancing the cut and the fill, while at the same time trying to integrate the result into its environment. The possibilities afforded by the site layout enable the design engineer to decide which earthwork strategies to use during construction. The best materials are kept for the capping layer in order to optimize the pavement structure. A borrow pit may be opened to compensate for a lack of materials. Creative measures for overcoming difficult spots are decided upon as, for example, vertical drainage, retaining structures. Already, some definite selections may be made for use and imposed at the construction stage. If the design engineer wants, he can build the main part of the strategy of his design on these decisions. Innovation in earthworks design consists in imagining construction scenarios in the context of local weather data and the nature and behavior of the ground. The geotechnical studies help to identify the best techniques for reusing soils and their suitability for being treated with hydraulic binders or lime. Where earthworks are concerned, a scenario consists in drafting an earth-moving plan, which serves as the battle plan for carrying out the project. This often complex document specifies the destination of each batch of earth from cut or borrow areas in time and space. An earth-moving plan is considered balanced if it requires neither borrow nor create spoil. To design such a plan, it is necessary to take the expected weather conditions for the construction period into account, as this may require treating a small or greater part of cut with lime. If from an ecological point of view, it is always desirable to achieve balance, from a technical or economical point of view, this choice may be less advantageous. The design engineer should therefore undertake a comparative study of these different aspects. This work enables the cost of the project to be determined according to a number of assumptions. The whole is submitted for approval by the owner. The design selected by the owner is now detailed to form part of the completed tender documents. The final specific studies are undertaken. These may include, for example, strengthening an unstable slope, establishing an area of soft soil, choosing a drainage system, designing treatment for the capping layer. At this stage, the quality assurance aspect of construction must also be considered. This step must follow guidelines in the Roads Department Circular. The design engineer converts the owner's performance quality requirements into set procedures. These procedures serve to define the quality required in construction as specified in the contract documents. The design engineer then drafts the first outline of the QAP in terms of procedures to be adopted by the contractor, which are then used as the basis for the organization of the QAP. Using this information, the contractor will analyze the difficulties of the project in question and will be able to draw up realistic costs to achieve the objectives set. The tendering process can now be launched. In conclusion, the quality of the tender documents depends mainly on developing a design progressively, on the accuracy and interpretation of geological, hydrological, and topographical investigations, on the suitability of the construction options in leading to the choice of the best basic solution,